All right. Just as we were talking about in the previous presentation, by the way, I'm Jason Rock from Dell, hardware systems architect. When you're looking for things like predictable performance, why is this necessarily a big deal and why we're covering it? If you think about a fact where you have a NIC that's defined by a spec, there's a very specific form factor that you have to hit. It's PCIe on the host connectivity side. That's very defined on how that's going to operate. There's a very specific way to test that and hit a specific performance level. On the front end, in theory, with the way the spec is derived, you can really put whatever you want on the front end side of it. However, most people, pretty much everyone's going to use particular front-end connectivity like Ethernet and specific speeds for that. But what about things like thermal? That's something that you have to get below a certain threshold to be able to operate within a particular system, but you need to set some sort of benchmarks and performance for that. The way I like to think about it is, when you go off and purchase a car, and especially, when I was young too, I wanted a fast car. So one of the metrics that we think about with a fast car here in the US, we wonder what the 0 to 60 mile an hour's rate is, and that's defined in terms of seconds. I'm assuming outside the US, that's probably 0 to 100 kilometers. That's probably why they picked the 60 number, if I think about that right now. But that gives you kind of at least some baseline metric that you can use in an area that's a little bit subjective. And then with thermal, it can't be that subjective. We need to know how these NICs are going to be operating within a system. So how do you get there to get to predictable performance for something like that? A lot of that's going to happen at the beginning. You have to consider that in the specifications. You have to think about the fact that if something like this is important, it does require text, it does require time, and it does require, especially in an open standard mindshare, to get towards a commonality between not only the system vendors, but also the NIC providers that are going to be able to provide something like this. A lot of that has to be enumerated within the spec up front. So when we think about things like thermal, we do have to have a specific definition of what we're going to be talking about. So within the spec, we define the airflow direction. There's the hot aisle and the cool aisle. We define specifically what that means within the specification. We also have thermal tiers. So we classify each of the NICs and how they perform based on the thermal tier, how they operate within different airflows and different ambient. Those are how the thermal tiers are established. There's also thermal design guides within the spec, as well as cooling card capability, even down to the front end of the bracket, how that's going to look. And done in some sort of a predictable manner, because I've seen being an area within the NIC market for a while, there's different ways that people want to present their brackets. A lot of it is for a branding, and other it's for pure functionality. Having some sort of commonality that's especially derived in the spec helps you get to predictable performance. From that point, it's easier for people that are building these cards to develop. So think about the car aspect. If 0 to 60 or 0 to 100 kilometers is going to be the metric of a fast car, obviously people are going to design with that in mind. And so we also have to know that too, as we're in designing these specs, is if you're going to set that sort of criteria, they better be very valid so that people can't necessarily kind of work around that and to try to get better marketing glitz with it. And the way you actually do that too is, as part of the specification, we define test fixtures. We defined a way how to evaluate it. And that's really what a lot of this presentation is about, especially as you're looking about the newer speeds. So this thermal test fixture, the goal of it, and we had presented this in prior summits, it's intended to provide a common thermal test platform, and it allows us to gauge comparable thermal data across a wide array of NICs. So not only just Ethernet NICs. If other people are developing different kinds of NICs, you're still going to evaluate the thermals in the same way. It's not necessarily, we've had this conversation in the community groups this past year as we've been looking at the tall, small form factor. It's not necessarily designed to favor the NIC vendors, and it's definitely not designed to be very similar to how every system design is going to be. It's skewed towards the system design. It's definitely going to be more in a compact, linear type sled aspect of a particular system design. But it definitely is. It's definitely one area we can all have like a common metric that we all agreed basically on how it's going to work. For the thermal test fixture, we have to factor all the different formats that we support within the specs. So today there is the small form factor, there's a large form factor that hasn't been very favorable as we kind of alluded to it with Damien and Hemel and Mike talk in the last session. We just recently released the tall small form factor, which creates more Z height for higher speed cards, especially with ones with connectors that are a little bit taller. And then we've been looking at, and today I think I called it the dual slot form factor. We still need a name for the newer form factor that we're considering. When we did the thermal test fixture a few years ago, Gen 3 and Gen 4 were the mainstream, and now we're trying to design it for Gen 5 in mind, and the fact it now works with that. But we have to think about it has to evolve to the next higher speeds, and so we're also investigating how it's going to work for Gen 6 and all the different front-end type connectors like OSFP. All this is currently contributed onto our wiki site, so this is all available material that people can build and modify and use for your own particular purpose. So as we were looking at for support for PCIe Gen 5, and eventually we're going to look at for Gen 6, we were trying to figure out, so the design that we made, we had to have some foresight of what PCIe Gen 5 was going to be back when we designed it. At the time, we didn't have availability of PCIe Gen 5 servers or NICs or even cables to do this sort of testing. We now have that. So Dell has the R760 server, and then NVIDIA has a 400 gig card that actually has PCIe Gen 5. And I worked with a couple of cable vendors. Samtec was one, Amphenol was another. Just randomly, I picked Samsung as a 12-inch. Amphenol's a 6. It's not really one is worse than the other. I just needed a little different baseline. One of the concerns we had at the time was, is there enough channel margin to make this work with the existing fixture? Or we're going to have to factor things like retimers or a whole complete new design for it. Luckily, it ended up working. Both cables worked out pretty well. So it is operational to use, and we've already provided that information out to the community. There is limited channel margin within it. You're definitely going to be bound by the cable itself, as well as the insertion loss of the NIC, of that particular NIC, and as well as the server too. So you have to have a little bit of foresight into what you're going to be using as your evaluation tool. But overall, it is able to be re-leveraged and work for Gen 5. We know for sure it's not going to work for Gen 6. It is at its limit of what it can do. We're going to have to refactor that design. In some of the prior presentations, there's been a lot of discussion on different sort of cabling and connector styles. That's something we're going to look into because we want to make sure that we're leveraging a lot of what's common. So the fact that then, all this, as you get it with the whole OCP thing, we all want to work out and make everything very similar. So, as part of, so we released the test fixture, a few years ago. We were always intending to provide some basically facilitate to do test automation. So similar to the SI test fixtures, most people don't go through and manually step through one and every little test case item. There's a lot of test and measurement equipment that does that for you. And they actually have screen prompts of plug this cable into these ports, press this X button 3 times to get it in this particular mode, and then it runs. It's very, self-prescribed, and it's really advantageous too. I don't know if you have your particular system companies like Dell, but it gets more challenging to find good signal integrity test technicians. And so being able to leverage not only what we're already doing for chem cards, but also having a way to do some sort of automation is pretty critical. So Dell worked with a company. We had an MCU on this board that we've always been meaning to enable to allow for test automation. There's signals like different power settings, so there's like an aux power and a main power. There's different serial buses that you do need to glean some data to figure out some thermal information like temp warnings and critical warnings. We needed to get that all under some sort of software so that it can be automated. We end up working with this contractor. They took the MCU and basically created a COM port through the USB. So you basically plug a USB into, say, like a PC, and it'll enumerate as a serial COM port. And then from there, you can pretty much grab whatever your particular software test automation scripting you want to do. Some people still use MATLAB. LabVIEW's the other, and then I tend to prefer Python. You just enumerate a serial port. You just modify what you need for the particular kind of the UI that was created for this, and then you're off and running. This code has been brought up to the steering committee to be contributed. Most of it is already approved. Still waiting for a few more votes to close that. But right now we have that code base already staged on a public GitHub today that it could be used right now. But and part of my call to action, I'll mention this a little further here. But it's all available. People can modify it, basically on the terms of the OCP license. Last little area of the topic I'll mention too is Damien talked about this a little in our prior presentation. As we were releasing the tall, small form factor test fixture, so we actually, as part of the spec update, there was not only the mechanical information on how to build a TSFF, but we also, within the test fixture, devised a new bracket so that you can actually do thermal testing with it. This particular bracket was designed in a way where we found out it didn't quite work out exactly how basically most common servers would work. In essence, what was happening, it's maybe a little bit difficult to see within these picture here, but on the one on the left, this is a hot aisle version of it where the heat is flowing from the host side out to the front panel, or out to the bracket. And then the other one is the reverse direction. What was happening, NVIDIA is the one that saw this, Anna, if you know her. What she noticed was we were not getting data that was aligned with simulation. And what we were finding through simulation, what was happening is air is basically leaking. And so in the picture with the hot aisle, what was happening is air along the sides of the card has to basically curve in to go out through the bracket. That's actually extra cooling that's not common for that NIC card. And in the reverse direction, it was creating a little bit of an eddy vortex, which is also giving extra cooling for these cards. So it was definitely not within simulation to the expected outputs of the data. So right now, we're part of the subgroup. We have a few folks that I have acknowledged here. We're all working through trying to uncover this. So we came up with two options. Number one was, the easiest one right now is we just built a new bracket that actually basically punches out side holes. And this is gonna be a lot more common when you would see in a particular server. This is the predominant one that we're looking at to solve this particular issue. We just got those built. Both Meta and Dell were in the process of building some. Luckily, I guess Dell won. We got ours built first. So we went in and donated one to Intel, one to NVIDIA, and I also believe one to Meta as well. So we can start doing some testing analysis to figure out if this solved the problem. If it doesn't, the other option that we're looking at is maybe using air baffles within the TSFF. Personally, that's not my favored one, because one of the things we want to have is commonality. This would make it different from how we test the SFF and the LFF. And then we may have to go refactor those thermal tiers. And that's something we don't necessarily want to do unless it's warranted. But right now, that's where we're at. We're hoping here in the next month or two, we'll have that solved. And if there's any new contributions we need to make or spec updates, we will definitely do so. So going along with that too is, for the group, our next steps is completing that testing and recommending the solution for that leakage issue. We're also gearing up for PCIe Gen 6, so we have to pretty much do that now so that we're aligned for when cards and systems are going to be available for that, and also that we can feed and provide data for them too. One call to action I have that it's not written here is when you contribute design material like this to the, or code bases to the OCP basically marketplace, you have to get it in front of the steering committee. And I know we had a big committee where there's a lot of new members. I encourage you guys, if you haven't voted yet, make sure to vote yes in some of these contributions so that the rest of the community can get that too. If you can go back in time, we do have some of this material out in the Experience Center. Obviously, the Experience Center is closed, so you can't look at that now, but a lot of this was available out at the Experience Center. But lastly, just, it's been our subgroup is very active. We actually do encourage new members to join us. We are continually creating new things within the NIC. We originally had Gen 3 and Gen 4. We now have Gen 5, PCIe Gen 5. I'm about to get to Gen 6. And I know with 800 gig and 1.6 terabits and this new form factor, we're going to need a lot of good new mind share to think about how we want to best all do this, especially if a lot of AI is in mind. Thank you.